All right, so the next question that I'm going to go over is question 7 from chapter number 4. This question gives you a balanced chemical reaction. 4NH3 plus 5O2 yields 4NO plus 6H2O. So 4 moles of NH3 react with 5 moles of O2 to produce 4 moles of NO and 6 moles of H2O. Now, the question prompts you with a mass 50.0 kilograms of NH3 react with 107 kilograms of O2. And then it asks what mass of NO is going to be produced. Now, this gives you 2 quantities and then asks you how much of a product is going to be generated. Well, this is kind of like a cheese sandwich or any sort of simple sandwich that you can come up with as a discussion for stoichiometry. You have 2 parts of one thing and 1 part of another thing. If you have 2 slices of bread and 1 slice of cheese, you can make a cheese sandwich, a single cheese sandwich. If you have 4 slices of bread and 1 slice of cheese, you're going to be able to only make 1 slice or 1 cheese sandwich. So that's what this is getting at. Now, that ultimately means that this is a limiting reactant or an excess reagent question. The fastest way that you can figure out your limiting reactant is we're going to do one simple thing. And the first thing that we're going to do is convert this and not talk about this as 50 kilograms, but we're going to talk about it as 50 grams. So we're going to say 50.0 grams of NH3. Then we've got to figure out what is the molar mass of NH3. The molar mass of NH3 is approximately 17 point, I'm going to call it 17.0 grams of NH3. That's 1 mole of NH3. Okay, then I've got my 107 kilograms. Again, I'm going to figure out 107 grams of O2. And I'm going to figure out that this is 32 grams of O2 is 1 mole of O2. So I'm going to figure out the number of moles of each one of these species. So 50 divided by 17 gives me 2.94, and 107 divided by 32 is 3.34. So I'm reacting 4 moles of NH3, or sorry, 2.94 moles of NH3 and 3.3 moles of O2. Now, what I'm going to do with these is I'm going to divide them by their coefficients for my balanced chemical reaction. NH3's coefficient is 4, and O2's coefficient is 5. So I'm going to say 2.94 divided by 4. And that is 0.735. Then 3.34 divided by 5. And that's 0.668. Okay, now I did all of this. I converted to moles, and then I divided the number of moles by my coefficient, and I figured out whichever number was smaller, that is going to be my limiting reactant. And as a result of that, I can figure out that my limiting reactant is O2. So now what I'm going to do with this is I am going to erase everything that I did for NH3. And I'm going to erase basically everything that I did for O2, because all that I need to figure out was which is my limiting reactant. Now what I'm going to do is I'm going to change color, and I'm going to add a little bit more to my dimensional analysis, because I need to take that 107 and I need to convert it to, I need to convert the 107. Actually, let me go ahead and erase. I'm going to switch it from grams to kilograms. So I'm going to do the right thing and switch it to 107 kilograms. And now I'm going to say convert it from kilograms to grams. So 1,000 kilograms is equal to, 1 kilogram. Let's try that one more time. 1 kilogram is equal to 1,000 grams. So now that I've got it in terms of grams, I can say my molar mass of O2, which is 32 grams of O2, is 1 mole of O2. Now I can use my ratio between O2 and NO, my molar ratio. So 5 moles of O2 is 4 moles of NO. 1 mole of NO has a mass of, that would be 30 grams of NO. Now what I need to figure out is how many kilograms I'm talking about. So I've got to use my conversion factor. There are 1,000 grams in 1 kilogram. And this is of NO and of NO. And that's where I arrive at my answer. So I'm going to say 107 times 1,000 times 4 times 30. Okay, and then I can divide that by, well, divide this by 32 times 5 times 1,000, and that's going to give me 80.25 kilograms of NO is produced. All right, that's all there was to that problem. I hope this is helpful, and I hope you have a good one.